In this event we use light sensor known as LDR and relay. Fire sensor is an input and buzzer is output. The flowchart explains powering the light sensor to 3.3 volts, relay to the 5 volts and 5 volts to the ESP32. Now connecting the light sensor to ESP32 is input and output to the relay from ESP32. Write the code in the Arduino IDE for the desired input and output device selected to perform this event. Assign LDR sensor in any digital pin, here we assign with GPIO32. Similarly, we assign GPIO33 for relay. To activate the pin function, we use the pin mode for LDR as input and relay as output. Now we code inside void loop. Read the LDR sensor value using digital read and temporarily store in any variable. Here we allocate LDR state and use the condition to check if the LDR sensor is low, relay will be activated. Here we allocate LDR state and use the condition to check if the LDR sensor is low, relay will be activated. Now save the program and click the tools and select the particular board and select the port and verify the program and finally uploading to ESP32. Here the circuit diagram shows the actual wire connections being used. Power the IoT kit by connecting the adapter. Connect the selected input sensor, that is light sensor, to the 3.3 volts power pin and the GPIO32 pin. Connect the selected output sensor relay to the 5 volts power pin and the GPIO33 pin. Now pass a light through the light sensor and see the relay function. Light-sensitive devices most often used to indicate the presence or absence of light, or to measure the light intensity. Applications of LDR mainly include street lights, light intensity meters, burglar alarm circuits. Relays are normally used in the control panels, manufacturing, and building automation to control the power along with switching the smaller current values in a control circuit.